All right, good morning, everybody. This is Panama Bartholomew with the Building Decarbonization Coalition, and welcome to our monthly, sometimes twice a month webinar series that the Coalition puts on called Building Decarbonization Coalition Presents. And we have a fantastic session today. I love all our sessions, but we got a really great one today. We have Bill Hosken from A.O. Smith that's going to be doing a new product unveil in the new product offering for them in the small commercial water heating space. So I'm just going to provide a little bit of a background on the coalition and the webinar series, and we'll get it right over to Bill. The Building Decarbonization Coalition, for those of you that aren't familiar with it, is a multi-sector coalition of utilities, manufacturers, builders, the design and construction community, local governments, and NGOs, all coming together to work collaboratively on building decarbonization in both the policy area as well as market-based solutions. So we work on collaborations that overcome some of the barriers and the challenges that we all face in building decarbonization. We adopted a roadmap as a coalition in January of this year after a number of months of development. And in that roadmap, we called for the state of California to bring about policies and market changes that would lead us to decarbonization, complete decarbonization of the building sector in the state. That includes by 2025 for residential buildings, zero emissions building code, and by 2028 for non-residential buildings. It included a call for the state to be implementing programs that bring about a step down of greenhouse gas emissions from the built environment of 20% reduction below 1990 levels by 2025, 40% by 2030, and then by 2045, a complete elimination of greenhouse gas emissions from the built environment, and dramatically increasing the sales of heat pump technology in order to allow us to meet these targets. And so our roadmap, very short, very accessible roadmap, can be found on the Building Decarbonization Coalition's website at buildingdecarb.org, only about 16 pages, and it lays out these goals and the framework for how we think we can, how the state can achieve these goals. Critical to those numerical goals were these really philosophical and overarching goals of what we think is going to be necessary for the state to do in order to be able to achieve these goals. And these 5 goals really lay out what the coalition thinks are the most critical guiding principles for the state. And so significantly increasing awareness of the benefits of building decarbonization and electrification to all market players, ensuring that both customers and professionals and builders and contractors are getting a good value proposition, a better value proposition out of electric than fossil fuels, making sure that our supply chain is ramped up and that we've gotten the barriers out of the way, and then making sure that all of our climate policies are aligned with our construction, energy efficiency, workforce development policies so that we don't have misaligned policies that are holding each other back. This webinar series that we put on every month is part of goal number 1, about overall increasing awareness. And so we bring in some of the top thinkers, disruptors, doers in the space to be able to talk to us all about what are they working on, what are they seeing, where are we moving. And so I want to thank you all for joining today to hear from Bill about water heating. We had over 70 different people register for this webinar. And so we can't allow everybody to be unmuted, and so you're all muted. The way we're going to do this is we're going to have Bill go through his presentation. He'll talk for about 30 minutes. He's going to be talking about his view from decades of experience working in hot water, and then talking about a new product that A.O. Smith is offering, their small commercial water heating product, and talking about why A.O. Smith is now entering into this space in this way. And if you have any questions while Bill's talking, please feel free to use the chat feature. Send us your questions and we'll ask Bill those questions at the end of the presentation. And so you all will stay muted. So with that, I'm going to turn it over to Bill. I'm going to stop sharing my screen, Bill, and please feel free to start sharing yours.
Great, thanks, Panama. Can you hear me okay?
We can hear you great.
Okay, great, good. Let me just go to share my screen.
And while Bill's doing that, I'll let you know, Bill is an expert at Zoom. When we did our practice run yesterday, he looked like he was in front of a green screen. He was throwing up pictures from all over the world. It was behind him. It was incredible. So if you want to learn how to really use Zoom, Bill Hosken's not only great at water heating, but also Zoom.
Hey,
I'm still a noob.
I'm still a newbie at it, but hey, thanks, Panama. It's Bill Hosken here. I'm a National Utility Program Manager here at A.O. Smith, and I'm one of a small group here at A.O. Smith that works exclusively with the energy efficiency and utility community, promoting our Energy Star high efficiency products as well as our grid connected products. So I think before we jump into the product, just spend a couple of minutes to give you a little bit of background about A.O. Smith. A.O. Smith has been around actually for 145 years. So I think for a commercial entity, that's a pretty good track record. We've got a lot of history behind us. A.O. Smith actually invented the technology of fusing glass to steel. That's the most common means of protecting a steel water heating tank today. And we've been manufacturing water heaters for over 80 years. So we are a multinational, multi-billion-dollar a year corporation, a little over 16,000 employees. And when we say A.O. Smith is our the company corporation based out of Milwaukee, Wisconsin, and it's also one of our brand names. But you may know of A.O. Smith products through other brands, such as State or American Water Heaters, Polaris, Takagi, Lochinvar. All of those are different brands that are manufactured by A.O. Smith. And we do both residential and commercial products. We like to say all commercially viable forms of technology. We do traditional tank type, tankless, both electric and gas, heat pump technology, boilers, and a series of solar tanks. So one of the things we're very proud of is this year we were awarded through Energy Star a Partner of the Year award. And there's a couple of reasons we were given that privilege of receiving that reward. One is the large number of different models of Energy Star products that we currently manufacture and offer to the market. And in addition to that, some of the innovative and unique means of helping customers find Energy Star products. So one of the things I'm going to share with you a little bit about today is a fairly new initiative we've undertaken, which is called the Energy Star Hub. But we've also done other things like our expert finder that would help consumers identify an Energy Star product, and the expert finder really views things from a consumer's perspective. So consumers typically aren't looking at first hour rating and UEF. They're really looking at, how many bathrooms they have and how frequently do they take showers. So we've kind of taken the typical means a consumer would shop for a water heater and built that around our expert, and then we will direct customers, always give them the option or choice of selecting an Energy Star product, assuming one fits within their use profile. So just a little bit about A.O. Smith here. Let me go on now to talk to you a little bit about this product, which we're pretty excited about. This product. We think we'll have a lot of success with this product in the North American market. But for any of you tech geeks on the phone, I'm sorry, I have to tell you, there's really nothing new or exotic about this product. So we're using traditional compression cycle, R134A refrigerant. And for many of you folks, you may not know, using heat pump technology for commercial water heating applications has been around for many, many years in Asia and Europe. It's just now that it's becoming new to the United States. And in fact, this particular unit, the core unit that we're going to talk about today, has been in production, I think, for 8 years. Perhaps 6 years ago, we took a look at this product and thought, is this a good product for the North American market? And at that time, we decided now the market wasn't quite ready for it. We've seen changes more recently in the last year to 18 months where we see market forces are changing. Energy efficiency is becoming more important. Decarbonization and the environment is becoming more on consumer and businesses' radars. And so we kind of reevaluated this and thought, well, maybe now we're getting close to being the right time. The first thing we did is we brought in a few of these units, and I made arrangements. One went to Southern Company's lab in Birmingham, one went to EPRI's testing lab in Knoxville, another one went to Oak Ridge National Lab, and one went to NEOP in the Northwest. And we kind of gave them these units and said, hey, put these through their paces, let us know what you think, if this is something that there might be a market for. Most of the responses we got back were very positive. So that followed with us doing some short field testing. That went well, and we made the decision to bring this product in and release a North American version of it, which is, the core is the same unit that we've manufactured for 7 or 8 years. What we've done is we've modified the power supply to meet the North American grid requirements, added an enhanced touchscreen color LCD display, and brought that product to market. So it's in stock, it's readily available, and looking forward to sharing with you some more details about that product today. I will note that we have a very high COP and it exceeds the minimum requirement. So it is an Energy Star certified commercial electric product. I think it's probably the only one you'll find on Energy Star website. If you look for certified commercial electric water heaters, you will note 3 different models if you go to Energy Star. So there will be a State, a Lock and Var, and an A.O. Smith. Those are all A.O. Smith related brands. So it fundamentally is the same product under different brands. So some of the things that really make this product kind of unique is it is a fully integrated commercial heat pump water heater. So kind of think of it in terms as being the big brother to the residential units. It's a pre-charged refrigeration system. It's all integrated, makes for a very simple installation. We'll talk a little bit more about that a little further on in the presentation. And you can see some of the things that we have here: 119-gallon storage capacity. It comes with 2 6-kilowatt elements, an upper and a lower. Those can be run simultaneously, and in addition to that, they can be run simultaneously in conjunction with the compressor running in those situations where we need a really fast recovery. So we got a maximum input combining the compressor and the resistive electric to about 20 kilowatts combined total heat input on this particular product. Just going over a few more of the other highlights here. 3.5 horsepower compressor. There's 3 modes of operation: efficiency, hybrid, and electric. In the efficiency and the hybrid mode, we're predominantly using the compressor to heat water up to 150 degrees. In the electric mode, then we're relying more on the electric elements to get up to 180 degrees. So most applications would be in that 140, 150 degree. If you've got a pot scrubber or something like that where you need 180 degree water, you can temporarily put it in the electric mode to get up to the 180 degree temperature. If you look at the Energy Star website, you'll see we have a coefficient of performance rated at 4.3, which is significantly higher than the minimum requirement for an Energy Star product. A little bit later on, I'll share some performance numbers with you as far as energy savings over traditional water heating technology and greenhouse gas reductions. Those numbers do not take into account any additional benefit, cooling and dehumidification benefit that we get as a result of running a heat pump unit. So I assume most of the folks on the call understand basically a heat pump is taking heat, we're extracting heat from the air, gets absorbed by refrigerant, goes through a compression cycle that boosts the temperature, and then that heat then gets transferred to the storage vessel. Sorry, I got a little bit of background noise here, right? No, oh, he's gone. So a byproduct of the heat pump process is cool, dry air and dehumidification. So we're pulling heat and humidity out of the air, and any of the numbers I show later on, we're not taking into account that the benefit that you may get from cooling and dehumidification. Conceptually, the product is an insulated pressure vessel with a wraparound multi-pass micro-channel high efficiency heat exchanger that's wrapped around the pressure vessel or the storage tank. That's our condensing unit. All of the other heat pump components are then brought to the front of the storage tank. So we keep all our electronics at the top. The middle front of the unit, we have our evaporators and the fans needed to pull air over the evaporators. Air is entering from the front side of the unit, and then on the lower portion of the unit, we have the compressor on the lower part of the unit. I'm not going to go through all those bullet points there. You can read those. An overhead view of the unit, you can see where we have the storage tank at the back, the electronics on top, and then below the electronics, we have the evaporator and fans, and then below that, we have the compressor. So there's two fans on this unit. Each of those fans pulls 1,400 cubic feet per minute. So we got combined air flow through of 2,800 feet per cubic feet per minute. So a pretty substantial amount of air being moved over the evaporator coils, and we need that to get this high level of efficiency. Just to give you an example of the simplicity of installations. I'm not sure why that popped up, but this is a photograph that was taken in our lab in Tennessee. And on the right-hand side, there is a standard resistive electric commercial 80-gallon water heater. And to the left is the CHP-120. So you can see from a physical size standpoint, it's a very compact unit. You've got 119-gallon storage on the left and an 80-gallon traditional resistive electric water heater on the right. There is a size difference, but it's not huge. The beauty is the ease of installation. So it's standard plumbing and electric connections on the CHP-120. The one additional plumbing connection, which you may or may not need to actually do anything with, is we have a hose coming out of the front bottom of the unit, which is the drip hose from the condensate coming off of the evaporator. So if you have a floor drain right next to the heat pump water heater, you can just direct that hose right to the floor drain. If the floor drain is not right there, then you're going to have to connect that hose to a condensate lift pump and extract that condensate to a drain close by. So pretty simple, straightforward installation. We'll move on, talk a little bit about some of the various applications we see for this product. And I'll just want to stress right now at this point in time, what's really important is that we select the right product for the application. Now, we do have 119 gallons of storage, but we're using resistive electric and a compressor for our heat input. So it has many applications, but we're not going to be replacing 100-gallon, 200,000 or 300,000 BTU high-efficiency gas water heater. So on proper sizing of an application, we have to make sure we have enough storage capacity to meet significant dump load requirements and enough recovery to meet the daily requirements. But it's both input and storage that's really important in properly sizing a commercial water heater. So just to give you a rough idea, at 12 kilowatts of resistive electric input or heat pump input, that's equal to about 40,000 BTUs. So although we have 120-gallon storage, if I have sitting next to it a commercial gas water heater with 300,000 BTUs of input, I'm not going to have the same, anywhere near the same recovery with 40,000 BTUs of heat pump versus 300,000 BTUs of input from a high efficiency gas-fired commercial water heater. So we have to make sure that we select the product for the right application. But that said, there's many applications where this product will fit very nicely. So we see the sweet spot for this product being applications that are using between 100 and 600 gallons per day. And I'll give you an example of that in just a minute. Before we do that, just a couple of the other operation requirements. We need a sufficient amount of airspace for this product to breathe properly, enough air volume for it to be able to extract the energy out of the air without causing discomfort. So we're recommending in a standard application access to about 3,200 cubic feet of airspace. So that would be roughly a room that's 18 feet by 18 feet with a 10-foot ceiling. That would be your 3,200 cubic feet. If we're in a kitchen type of application, we can probably get away with a smaller cubic space because you tend to have more heat and humidity being emitted into kitchen airspace. And we really think this product will do exceptionally well in the food service industry because many kitchens and restaurants have AC running every hour of operation. They need that AC to extract the heat and humidity. And remember earlier I said when the heat pump is running, we're not counting the additional benefit of almost 2 tons of cooling and dehumidification that this unit is providing. So in a kitchen installation environment, we're getting the added benefit of offsetting a lot of that AC by having the heat pump extract a lot of that heat and humidity out of the air. So we see this being a great fit for many applications, quick service restaurants being really a prime market for it. My past experience working with solar water heating systems and doing energy audits on some quick service restaurants, typically we found that an average quick service restaurant would use between 250 and 400 gallons of hot water per day. It fits right within the sweet spot for this unit, where we're going to be relying predominantly on the heat pump for our energy source and being able to provide them a sufficient amount of water for their end of shift cleanup, and just fits so nicely within those types of applications. Smaller fine dining restaurants, medical clinics, veterinary clinics, comfort stations, gas station rest stops, some multifamily applications, and really any other commercial application that would fit roughly within that 100 to 600 gallons per day of hot water delivery. We could do a little bit more than 600 gallons per day, but then we're starting to rely more heavily on the resistive electric. We really want this to be an energy efficiency product and minimize the use of the resistive electric, except for those situations where we need a short amount of fast recovery. So 100 to 600 is really the ideal sweet spot for this particular product. Just the last point here. Here's a photograph of. Oops, sorry. Here's a photograph of one of the field test pilots that we did. So this was actually one of our overseas units we had brought in. We'd modified the power supply. You can see the screen at the top on the photograph on the right-hand side. The user interface screen was kind of patched on there. That was a pre-production unit. We've since integrated the display into the unit. It's now a color touchscreen display. But the other physical characteristics have remained unchanged. In this particular case, it was a quick service restaurant, a very simple installation. There was a floor drain actually right at the bottom right-hand side of the heat pump, so we just didn't have to do anything for the condensate, just pull the tube out of the bottom of the unit, point it towards the drain, and that part was done. Standard electric and plumbing installation connections. So from a plumber standpoint, it was really no different than a standard commercial electric water heater installation. The unit's a little bigger. We had to make sure there was ample access to air, which in this case there was. So the basic installation was no more complicated than a standard commercial electric. At the beginning, I indicated that the compressor unit, it's a sealed pre-charged compressor unit. So there really is no maintenance required on the compressor. Contractors don't have to worry about refrigerant recapture or any of those types of things. It's all a sealed unit designed to remain sealed over the life of the product. So very simple and straightforward product from an installation and maintenance standpoint. I'll change here a little bit. I talked a little bit earlier about our Energy Star Partner Award, and one of the new services that we're offering, and that is our Energy Star Hub. So Energy Star Hub is really a depository of information, and I'll go through what some of those types of things are. Everything on the hub is related to Energy Star products offered by A.O. Smith, and it has to be only Energy Star rated products and information in the hub, and that's how we're able to use it in conjunction with the Energy Star logo. So our intent here really is not so much to promote A.O. Smith as we're trying to promote Energy Star and energy efficiency, because we know if we promote Energy Star and energy efficiency, it will be good for the technology category. So and why it's going to be good, I'll just share with you, the Consortium for Energy Efficiency did a survey. I think the last one was back in 2016, and they surveyed a group of consumers regarding Energy Star and awareness of the Energy Star brand. So they found 91% of consumers recognize the Energy Star logo. 74% of consumers surveyed said it was a significant or somewhat significant factor in their choice of a product. 80% of people that purchased an Energy Star product would recommend it to others. So we see there's a tremendous opportunity here to work with Energy Star, support the Energy Star brand, which is going to be good for our industry and good for specific technologies like heat pump for water heating. So within the hub, if you want to take a look at the Energy Star hub, you can go to our main A.O. Smith product page, which is under www.hotwater.com. So just remember hotwater.com. About halfway down the page, you can click on the utility programs icon, and that will take you right to an Energy Star registration page. And it's a simple and free registration to get registered on the Energy Star hub. So we've included in the Energy Star hub a number of different things. I will say that the majority of items on the Energy Star hub are really geared towards distributors and contractors, right? So we can build all these great products, we can talk about them, but if we don't have our distribution supply chain partners, distributors and contractors informed, knowledgeable, and offering these options to their customers, they're not going to get sold. So a lot of what we've done with the Energy Star Hub is really to provide tools and education for our supply chain partners so they can have the comfort level that they need in order to be able to start offering these products to their customers. So one of the things we've recently posted, or may not even be on the hub yet, should be within the next few days, is an infographic that we've put together. This was actually the information was gathered by my counterpart, Francois Laberceur, who many of you may know. He's done a great job, I think, where if you look at this, we're really trying to educate our supply chain partners. Hey, here's a great technology. Here's a great opportunity for you to take advantage of this. Product. So if we're looking at this product, the map down on the lower right-hand side is giving you an idea of where we have a high population of commercial electric water heaters going into the marketplace. So although we know there's a lot of gas water heating in the state of California, if we look at commercial electric water heaters, and we look at from our vantage point, where a lot of our product is going, we sell a lot of electric commercial water heaters in the California market. And these are specifically units that fall within the range where the CHP-120 would be a great Energy Star alternative to a standard resistive electric water heater. On the left-hand side of that, you can see, based on the national average, to operate a 12 kW, 120 gallon commercial electric water heater at 350 gallons per day with 140 degree set temperature, your operating cost based on national average electricity costs about $2,780 a year. That drops way down to $1,060 for the CHP-120. Or savings over the lifespan of the product of about $13,500. So, and we're estimating an 8-year life expectancy on a commercial product, which is fairly typical. So our target for the CHP-120 equipment and installation cost for a straightforward, I'll call it fairly straightforward installation, similar to that quick service restaurant I showed you previously, is about a premium of about $4,000. So in this case, if I'm saving $2,000 a year, my simple payback before any utility incentives would be roughly 2 years. And our experiences for commercial customers, if the additional capital or CapEx expenditure is 2 years or less, we have a reasonable chance of them making the switch over to a more efficient product. Hopefully for any of our utility friends on the call, we're really looking forward to you folks to be able to work with us. This is a great opportunity for you to help meet your energy efficiency mandates and put some marketing dollars and some product incentive dollars to help reduce that payback period even more. I said earlier that we think one of the great places for this particular product will be within the food service industry. And one of the areas that we've already identified, but we're really excited about is those small to medium and quick service restaurant applications. So that map on the lower left-hand side is showing the increase in food service restaurants that has taken place between 2000 and 2015. Now, we have to remember, sometime in there, we did have something called the Great Recession, but those patches there with the dark orange, there's been over a 30% increase in the number of quick service restaurants in any of those dark areas, a little bit less in some of the lighter areas, but this continues to be a significant growth area within the hospitality industry, and really is a sweet spot for this product. So we're really excited about that being a great opportunity for restaurants to save money, for our distributors and our contractors to become familiar with new technology and serve their customers better by offering them a more efficient option over the standard water heater. Now, also on the hub, we've gone one step further than just providing national average and generic information. On the right-hand side there, you can see my mug on the right-hand side and Jerry Winslet on the left. We produced a short 5-minute video. It's a general audience target, but really maybe more so for contractors. And we're using that video to convey to contractors the ease and simplicity of installing this product, being a unitized, pre-charged package system. You don't have to be concerned about refrigerant recapture and new licenses, new equipment, and new training. It really is a straightforward, easy installation for you as a contractor. So we're looking for folks to give us additional input going forward on making other videos and other tools that you may find, hey, if we only had this, it would make it easier for these contractors to convey to the consumer. Or if you did a video like this would be a great tool for the contractor to convey to their customer. So we welcome any and all input on what we can do, tools or information we can add to the Energy Hub to make it, Energy Star Hub to make it better in the future. Now, one of the things we've done in the Energy Star Hub, national numbers are great, but we know energy prices are not the same across the country. So we've gone one step further and are developing tools that are regionally or really state specific. So you remember a couple slides back, I showed you a slide and the national was $2,800, I think it was, operating cost, the national average. This one was done for California. So because electricity rates are higher in California, your annual operating costs are higher. And look at the savings. We were $8,000 before, now we're $18,000 energy savings compared to a standard resistive electric water heater over 8 years. I think that's a very compelling story for end users and for contractors to say, hey, here's an opportunity to offer your consumer a product that's going to do a better job for them, a better job for the environment, and it'll give you an opportunity to make a few more dollars on your sale and installation as well. A couple of last things here I just want to share with you. We're looking at specifically talking today about the California market. So I want to give you some examples of what the energy savings would look like compared to other traditional technologies. So in all of these cases, we've got 4 cities: San Diego, Los Angeles, San Francisco, Sacramento. We've done the same hot water use, 350 gallons per day within our sweet spot, set point of 140 degrees. These are all indoor units. So the really factor that distinguishes the difference between these is the average inlet temperature for that region. So that really is the one differentiating factor that takes more energy to heat colder water than warmer water. So the third column over is a traditional resistive electric water heater. In the case of San Diego, and I'll just use San Diego as the example here, to heat 350 gallons per day of hot water in San Diego, it's going to cost you energy-wise about 21,950 kilowatts of energy a year. If we go to the heat pump, that drops way down to under 5,000 kilowatts of energy per year. If they're currently using a condensing commercial gas water heater, I've converted BTUs to kilowatt hours just to give an apples to apples comparison. That would be 22,000 kilowatt hours worth of energy. In this case, it'll be natural gas, not electricity. But you can see there's still very significant energy savings with the heat pump compared to either electricity or gas, strictly looking at energy use itself. So the last 2 columns on the right is your savings. So a heat pump compared to a resistive electric water heater is going to save you almost 17,000 kilowatt hours of electricity a year. And compared to a gas, it would save you roughly 17,000 kilowatt hours worth of gas, which would be X number of BTUs per year that you would be saving compared to a high efficiency, 92% efficient condensing gas commercial water heater. We are talking with the Decarbonization Coalition today, so I thought it would only be appropriate to also take a look at what is the impact on greenhouse gas reductions. So we're using the latest information we had available for California, which is 2017, indicating that for each megawatt hour of electricity produced, there's 249 kilograms of CO2 as a byproduct of that. So again, looking at San Diego, the same parameters, 350 gallons today, 140 degree set temperature, using electricity based on today's generation mix, you'd be creating 5.47 tons of carbon dioxide. If that unit was replaced with a CHP-120, that drops way down to 1.24 tons. If we take a look at a 92% efficient commercial condensing gas water heater burning natural gas, that's going to produce about 4.1 tons. So any way you slice it, there's very significant greenhouse gas reductions going to a heat pump water heater as compared to either standard resistive electric or a high efficiency condensing gas commercial water heater. So in the case of electricity, you're saving over 4 tons a year and almost 3 tons of greenhouse gas reduction compared to a high efficiency commercial natural gas fired water heater. And that kind of wraps things up for me. Of course, we're open for questions. So Panama, I'm going to, I'll just leave my screen open, I guess, for now in case I need to go back, but turn it over to you if there were any questions.
Great. Thank you, Bill. Man, we're going to have you give every presentation on the Decarb Present series. You were fantastic. And the chatter on the chat, folks really excited about this product and a lot of questions for you. So first one being, could you repeat what refrigerant you guys are using in this unit? Uh-oh, Bill, you still there?
Sorry, I put myself on mute. R134A.
R134A, fantastic. Barry Hooper, I'm gonna unmute you and give you a chance to ask your question directly since it started quite a conversation in here. It looks like I'm missing you though on here. So there's definitely an interest in getting a unit together to be tested to be able to put it into CBEC commercial, CBEC com. So I think we're going to be contacting you afterwards about that. So a question from Farhad from TRC. He had 3 questions. Can it be ducted to the outside, this unit?
Currently, we don't have any ducting kits available, and normally the rule of thumb for heat pumps is you move air inside the building envelope or you move air outside the building envelope. You don't normally move air in between the two. So if we were to duct that conditioned air, basically, and I should point out, when you have air coming in the front sides, we extract heat from that air. Your discharge air is going to be about 10 degrees cooler than the intake air. So if the kitchen is 75 degrees, the exhaust air coming out is 65 degrees. So 65 degree air sounds cool, but if we're discharging it outside when it's 45 degrees, now I need more makeup heat to bring into the kitchen because I may cool down the kitchen too fast or other commercial application.
Thank you. Still from Farhad, what's the EWT for the rated COP? And could these units be used for recirculation applications if needed?
We can do recirculation. Let me see. Bear with me a second. Let me go through my cheat sheet here real quick. I think it's 1.5 gallons per minute flow rate. As long as the flow rate is not too high, we can do recirculation. And I can't find that number right in front of me. I think it's 1.5 gallons per minute. Might be a little bit more than that, but I can shoot you a note afterwards, Panama, just to confirm that.
Great, fantastic. And then lastly from Farhad, will this model be responsive to utility signals at some point for things like demand response?
Well, that's a good question. Today, this first generation, we do not have grid connectivity to it. Going forward, we may do that, but we want to kind of educate people a little bit too on a commercial water heater. So the reality is a commercial water heater in most cases is mission critical to that business, right? They need hot water when they need it at the temperature in the volume that they need it. The second point, technically, if we look at a commercial water heater compared to a residential water heater, we have a relatively large amount of storage and a relatively small amount of input. So, we'll have a 50-gallon residential water heater with 4.5 kW of resistive electric input. In a commercial application, you may have a 50-gallon commercial electric water heater with 36 or 54 kW of input. And you need that because you're looking at a very fast recovery. You need that high amount of energy input for that particular application. So with this unit, the ability to impact during those peak demands is really going to be somewhat limited, because it being a mission critical product for the business. Now, going forward, we probably will be looking at adding grid connectivity. And in the case of California, if it's a restaurant, what you'd want to do is load up that heat pump, before your evening peak hours, and then try and minimize it as much as possible coming on during those minimum peak hours without interfering with your business, your ability to run your restaurant and wash your dishes when you need to.
Great, fantastic. This is from Georgia Toland. She writes, for Department of Health applications, there are sizing and recovery requirements to make sure delivery at required temperatures is available at all times. Is it possible to determine an actual recovery with these units?
Yes, we can do actual recoveries with these units. One of the benefits we do have with this particular unit is we do have a 12 kW of resistive electric, so that goes a long way to being able to meet those specific demands, because that's a known quantity of input. There is some variability on input with the compressor depending on the temperature and the humidity level of the surrounding air.
Great, thank you. This is from Tom Cabot. Have you ever provided a chart of gallons per day and associated ton hours per day of cooling provided, or anything like that? Or gallons per day and associated kBTU per day of cooling provided?
Well, actually, ASHRAE had put together a hot water use table that I'm trying to get my hands on a copy of that we can distribute. So ASHRAE actually produced a hot water use table. I use this a lot when I was doing solar work, so you could look at the specific commercial application. If it was a quick service restaurant, as an example, you could look at number of meals served, and it would give you a medium, a low, an average, and a high hot water use volume. That was very helpful, but I don't have that. I don't have access to something I can distribute. Today. I'm still reaching out to ASHRAE to see if I can get hold of something like that, but ASHRAE does have such a thing.
Great, thank you. Question from Tom Matheson. What is the MSRP on this unit? What you can tell us now.
Well, when it comes to pricing, everything goes through our distribution partners. So we don't actually deal with pricing ourselves here at A.O. Smith, except directly with our distribution partners. I can tell you that the target price for this unit, the premium market price in your local market for this unit over 120 gallon 12 kilowatt input standard commercial electric water heater is about $2,500. So if a standard 12 kilowatt 120 gallon water heater is $4,500, this or $5,000, you'd be looking at, say, $7,000.
Gotcha. Thank you. Understand why you have to answer in that way. Would small to medium laundromats be a good application for this product?
Probably smaller ones would be. Here again, it would be looking at the specific washers, what their gallon capacity is, how many wash loads they're doing a day, and making sure that it's going to fit within that application. Probably like if you have a separate water heater in a multifamily that's, serving, 5 or 6 washing machines, I'd have to look at the actual calculation. Something like that would probably be a good application. We want to make sure, again, it's sized appropriately for the application.
Absolutely. Yeah, we want to be giving heat pumps a good name, not a bad name.
Right. And I was just going to add one other point in the. So I said that our calculations are about a little under 2 tons of cooling benefit. So if I'm doing 350, 400 gallons a day, in the economy mode, that's going to be about 7 hours of runtime. So we want to be clear. One of the reasons we don't try and monetize that cooling benefit, it's not an air conditioner. It's a water heater that has cooling and dehumidification benefits. So we don't want people thinking, hey, I'm getting an air conditioner and a water heater in one. It will only provide those cooling benefits as it's meeting hot water, as it's meeting the hot water requirements. So if you want it to be an air conditioner, once you get the hot water tank full, open the tap, drain all your hot water, and keep it running. But that's not very environmentally friendly.
Exactly, not what we recommend.
We don't recommend that.
Yeah, from Claudia Pingator, is this currently, we know it's a new product, but is this currently being incentivized by any utilities or other programs?
I believe there are some utility programs around the country. One of the things that our group, Francois and myself in particular, are reaching out to utilities. We'll be at the Energy Star Partners meeting next week, and trying to get in front of as many people as we can. This is a pretty new product for the North American market, and so it's one of those things. There hasn't really been anything in a commercial electric water heater Energy Star certified. So I think we're still early in the game. There are some utilities offering some incentives, but we really need to see that expand.
Fantastic. Well, we have a number of utilities and consultants to utilities on this webinar today. So hopefully some good ideas springing out of this. Is it possible to lock out the resistive heating elements or require manual intervention before they're engaged? Steve Oliver says he thinks that behavior might change if users appreciate how frequently or hopefully infrequently they're actually used.
I don't believe we have that currently built into the unit. So it's something certainly we would look forward to that input. Our main concern right now is to provide a product that's going to serve the business needs of the commercial user. And what we don't want is somebody getting the product, having a bad experience and saying, I spent all this money for this high efficiency product. You know what, that old clunker I had, that I was 9 years old that finally had to replace, it provided all the hot water I need. This new thing doesn't. So I think in time we will get to that point, but we're very protective of our brand, and we want to make sure consumers have a good experience, whether it be residential or business. Technically, it's something we could do. It's just something we haven't made the decision to do just yet. We're really not sure that the end users are quite at the point to be able to really appreciate that and use that.
Great, thank you for that. I just want to take a moment, Bill, and really thank you and A.O. Smith for being really outward about your support for the Energy Star program. That program is currently under attack and at risk of being defunded, and I think it takes some real courage and fortitude on behalf of companies like A.O. Smith to stand up and provide support for that program. So I wanted to thank you on behalf of the coalition for taking that stance and using your voice in that way. A question from, go ahead.
I was just going to say, I just need to, mention that the work being done from our government affairs folks, both Ashley Armstrong and Joshua Green, is of paramount importance. They are the ones that are really working at the legislative level and helping support the activity that Francois and I and Brandon Stepanek are doing in the field. So, we rely very heavily on their support, and we're kind of work collectively as a team. If we, this is it's good for everybody if we're successful at promoting these higher efficiency products. Our customers, our distributors, our contractors, the end user, the environment, everybody wins by implementing more efficient products.
Great. A question from Nick Durr. If the installation space does not have 3,200 cubic feet of space, can louvers be utilized?
Yes, we'd have to take a look at the specific location and make sure we've got access to put in large enough louvers, provided there's an adjacent room. I'm sure we could do that. We'd have to look a little bit case by case, but similarly to, we can do louvered doors on our residential unit if it's in a more of a confined space. So the answer is yes, but we'd have to be look at application specific, case by case.
Okay, great. Follow-up question about locking out the resistant heating elements. Since it's not possible to lock out those elements, is there at least feedback on when and how often it is used?
Yeah. So in the economy mode, there's a high preference to the heat pump. So if there are only modest hot water draws from time to time, we are not going to be invoking the resistive electric elements. So it's only when there's a large hot water draw and the average tank temperature drops below a certain amount, we see the volume of hot water available decreasing significantly. At that point in time, we'll invoke the resistive electric elements. So again, the unit is designed to provide maximum energy efficiency, but at the same time meeting the demand needs of the end user.
Great. And then I think the last question, great timing, from Tom Cabot again. Would moving both resistance elements to the upper location allow you to achieve a higher than 150 gallon first hour rating? For example, using the hour to deliver 170 gallons of hot water while leaving the tank bottom cooler at the end of the test?
I don't know.
Yeah.
But I do know, we've designed it in such a way, here again, to be, to meet a commercial application. And that's because we're looking at having sufficient recovery. Heat tends to migrate to the top, but we're looking to have a sufficient dump load of hot water available, and that's why we use the upper and the lower elements. And if it happened to be in a location where the air temperature dropped below the 45 degrees in that application, then it's going to revert over to resistive heating, and in which case you'd want the upper and lower element to ensure you've got a supply of hot water.
Great, wonderful. Bill, you are a treasure. You did a fantastic job today. Thank you so much for joining the webinar. All of you who joined, thank you for joining as well. This is the caliber of presenters that we have on our monthly webinar series. So thank you all for joining today, and I hope you continue to come back to the webinar series to hear from leaders in the field like Bill talk about new activities, products, programs, and policies that are being brought to market. So thank you so much, Bill. Thank you all for joining. We're going to end the webinar now. There's Bill's information. We'll have the recording of this webinar as well as the chat dialogue up on the Building Decarbonization Coalition's member website by the end of the week if you want to go back to it at all. Thank you again, Bill. Thanks everybody for joining, and have a great week.
Thanks, everyone.